Chapter 4, Lesson 3, Functions. You will be able to find function values and complete function tables. To find the value of a function for a certain number, substitute the number for the variable x. Find each function value. So here we have this symbol. That italicized F really stands for function. So this really means the function of x. So really, what is x doing? Okay. So when it wants us to find the function of -3, what we are doing is plugging in -3 for x in this equation. So the function of -3, again, all I'm doing is rewriting the equation, but instead of x, I'm putting the -3. From here, we just simplify. 2 times -3 is -6 plus 1, which is -5. Letter B. Find f of 2 if f of x equals x minus 4. So f of 2 equals, plug in 2 where you see x, bring down everything else. 2 minus 4 is -2. Letter C. Find f of 12 if f of x equals 1/2 x plus 5. So I'm finding f of 12. So I'm plugging in 12 where the x is and bring down everything else. 1/2 times 12 is 6. Bring down the plus 5. And 6 plus 5 is 11. Letter D. Find f of -10 if f of x equals x plus 13. So f of -10 equals, plug in -10 for x, bring down the plus 13. -10 plus 13 is 3. So really, it's just substitution. Function tables. You can organize the input, rule, and output into a function table. Choose 4 values for x to make a function table for the following functions. Then state the domain and range of the function. So we have f of x equals x plus 5. So in this box, that's where f of x equals x plus 5 is. Just like in the previous lesson when we put y equals. The equation goes in the center box. And we need to pick 4 values. I like to choose negatives. I like to make sure I have a 0 and also a positive, just to get a decent range of values here. So let's start with -2, -1, 0, and 1. And again, I am picking the values to plug in. Make sure you get at least a negative, a positive, and 0 in there. All we do is plug them into the x plus 5. So -2 plus 5 is 3. -1 plus 5 is 4. 0 plus 5 is 5. And 1 plus 5 is 6. So our domain, remember, are your x values. Since we used a table, we can use the x values from our table. -2, -1, 0, and 1. And our range, or y values, 3, 4, 5, and 6. Letter B. F of x equals x minus 7 goes in the center box. And let's pick some values. This time, just to switch it up a little, I'll pick 2 positives instead of 2 negatives. So -1, 0, 1, and 2. And plug in all of these numbers into x minus 7. So -1 minus 7 which is negative 8. 0 minus 7, which is negative 7. 1 minus 7 is negative 6. And 2 minus 7 is negative 5. The domain, negative 1, 0, 1, and 2. Those are your x values. The range or y values, negative 8, negative 7, negative 6, and negative 5. The variable for the domain, x, is called the independent variable. The variable for the range, or y, is called the dependent variable, because your y, your range, depends on your x, or domain. Okay, so x is independent, and y relies on, or depends on, your x, your domain, therefore y is dependent. For each situation, identify the independent and dependent variables, domain, range, and function, and finally, answer the question relating to each situation. Okay, there are approximately 770 peanuts in a jar of peanut butter. The total number of peanuts, P of J, is a function of the number of jars of peanut butter, J. Independent variable. The total number of peanuts is P of J, and it's a function of J. Okay, so our independent variable in this case would be J, which represents the jars. Which means our dependent variable is P of J, okay, which represents the number of peanuts. The domain. Now this time we don't have a table to look off of, so we can't really state actual values for the domain. But let's think about it. The domain are your x values, so are your independent variable. So is your independent variable. So if the domain is talking about jars of peanut butter, think about it. Can we have negative jars? No. Can we have fractional jars? No. We can only have whole numbers because you can only have a whole jar. You can't have a fraction of a jar. Okay? So the domain, we would say, is all whole numbers. Again, the reason being, we can't have fractional or negative jars. The range. Oops. The range. These are going to be your y values. If we had, or your peanuts in this case, range is dependent variable. So let's think about this. We have our domain as all whole numbers. Okay? So if I have 0 jars, I have 0 peanuts. If I have 1 jar, I have 770 peanuts. 2 jars, I have, 770 times 2. 3 jars, 770 times 3. So really our range is going to be multiples of 770 because our domain has whole numbers. So our domain has whole numbers, which means our range must be a multiple of 770 in this case. Our function, that's really asking for our equation. Since it asks for a function, we will put it in function notation, which means you don't put y equals. You put the function equals. So P of J equals. And it looks like there are 770 peanuts in a jar. So our function would really be P of J equals 770 times the number of jars, times J. And last but not least, how many peanuts are in 7 jars of peanut butter? We're starting with our function, but instead of J for jar, I have 7 jars, so plug in 7 where J is. So P of 7 equals 770 times 7. And 770 times 7 is 5,390. So our answer here is 5,390. 390 peanuts. Let's take a look at another example. A scrapbooking store is selling rubber stamps for $4.95 each. The total sales, f of n, is a function of the number of rubber stamps sold, n. So our independent variable is n, which represents the stamps. Our dependent variable is f of n, which represents the cost. Domain. So we're kind of in the same situation as before. You can't have fractional stamps, you can't have negative stamps, so your domain is all whole numbers. Because this is all whole numbers, our range has to be a multiple, in this case, of $4.95. Our function would be f of n equals $4.95 times the number of stamps. And then determine the the total sales for 5 stamps. So we're going to start with this equation. F of n equals 495n. And really what we're going to do is plug in 5 for n. And we get 24.75. So our answer is $24, because it's a cost, and 75 cents. Letter C. A hot air balloon can hold 90,000 cubic feet of air. It is being inflated at a rate of 6,000 cubic feet per minute. The total cubic feet of air, A of t, is a function of the time in minutes, t. So our independent variable here is t, which represents our minutes. Our dependent variable is A of t, which represents the, we'll say, air in the balloon. Okay. Domain are our x values. Now this one's a little different from the previous ones. We are filling an air balloon, so we're talking about how much air is in that balloon. We can't have a negative amount of air, but we can have a fractional or a decimal amount of air. So in this case, the only thing we can't have are negative numbers, so we would say our domain is all positive numbers. Our range, well, remember, your range is dependent, so it depends on your domain. So if our range, or excuse me, if our domain is all positive numbers, our range, it doesn't have to be a multiple per se, but it can be any rational number between 0 and 90,000. And the reason it can't be bigger than 90,000 is because the balloon can only hold 90,000. So once we've reached 90,000, that's it. Our function, A of t, equals 6,000 t. Determine the total amount of air in 6 minutes. So again, we're starting with our equation, our function, but instead of t, we are plugging in 6 minutes. And we would get 6,000 times 6, which is 36,000. So 36,000 cubic feet. was a limit